Hello everyone. Today I'm going to go over a bit of how to solve one of these problems that I've seen on AMC tests. So this one today is a grid problem where they tell you you can only either move up or to the right. And they're trying to figure out how many different ways can we do this. So here's two examples. You can move all the way to the right and then up, or you can take any path where you're going up and to the right, as you can see with these green arrows. And as I was trying to figure this one out, I was sitting in my biology classroom and they have tiles on the floor. And so I came up with this as I was looking at the tiles. My idea was if we have two spots on this square and we know how many ways they can reach the end, then we can add them to find the answer. So for this one, supposing that from this corner, there's 10 paths to get to the end, and there's 2 paths to get to the end here. In total, we can add them together, and there will be 12 paths as long as they're independent from each other. So the answer to this would be 12. And we could add another one here. It would change the problem, of course, because if we had 3 here, then now instead of there being 2 at this corner, there would be 5 because you'd have to add the different paths because these all come here. So if we just look at a single square, we notice that if we start at the end, there's one path from the end to the end. That's what we'll start with. And then at each corner, there will also be one path from the corner to the end. So working our way from the end to the beginning, we can add this one and this one to find that there are 2 paths, right? There's to the right and up that way, and then there's also to the right and up this way, or up and to the right, opposite order. All right, so now if we're looking at a bigger picture, like this one over here, what we want to do is we start with 1 in the corner. There's one path from the end to the end. We're just analyzing it, looking from this corner. And then from this corner over here, we notice there's also just one path. This will start to compound. As we see, there's one here as well. Now from this corner, like we saw here in the small square before, there's going to be 2 options. We can go to the right and up and to the right. And that's just the sum of these 2 right here. We can continue to do that. We have 1 here, which is still the path all the way to the end. And now we have 2 plus 1 is 3 for this corner. And as you can see, we can continue filling it out until we get to this end product right here. And so our answer is 792 because we went through each time and we found our way to the end. Now, there are other ways to do this than just with squares. We could split it down the middle right here. This would make it a bit trickier, but it's still the same concept. But now, instead of having 2 at this corner, you add up the 1 here, the 1 here, and the 1 here because they all meet at this corner. So now it would be 3. And you could redo the entire thing if you were to cross each of these through. It would make it a little more challenging. You can try going through that one on your own. This is already a big number, so maybe try it with a 3 by 3 if you want to. And the interesting thing about these problems is it actually, if you twist it sideways, it starts to look familiar. You have 1, 1, 1, 1, 2, 1. This is Pascal's triangle. And so one of the shortcuts we can find here is our answer is going to be its location on the Pascal's triangle. So you can see here, we moved 7 down and 5 to the right. So it's a 7 by 5 grid if you take a look at this section right here. Just like the grid we had. It'll continue to fill out that way. No matter what shape we have, it'll work. And it shows up twice because we can have our dimensions the other direction as well. And if you remember, Pascal's triangle simply means a combination. So it'll always be the row plus the column number if it's a rectangle. And then on the base, it will either be 5 or 7, the row or the column number, because they both are the same. They add up to the sum of the 2. And so that will be the same. So that's my short video on how to find answers to these grid problems where it tells you You have to get from the beginning to the end of this maze, and you can only move up and to the right. Of course, it would be infinite if we allowed for anything else, because you could go back and forth to the right and left indefinitely. So with these restrictions of up and to the right, or if it was down and to the left, whatever it may be, you can start from the end and find a number of paths going from any point to the end. So from this point, it would be 5 to the end. And you can find your answer by continually adding until you get to the corner. Thank you for watching.